So today we're going to be talking about statistics and probability. The first thing that we're going to start with is some basic statistics and what that means, and then we are going to jump into probability with an understanding of how we might use probability in the real world sense. So when we talk about statistics, there are a few vocabulary words that we really need to touch on. One of those things is data. Okay, so data is each number in a set. And this can be something like if you ask what's your favorite color to 100 people, blue as an answer would be one data, and one person answering that one blue would be one data point. If you asked a group of people how tall they were, having someone say 5 foot 5 inches would be one data point in your whole question set, in your whole answers. So when you start to go back and look at your data, you can see, oh, one person said that they were 4'11", 5 people said they were 4'12", that's 5 foot, and so on and so forth. So data is an important piece of statistics because we're actually gathering information. Now, the entire people that you are gathering information from is called your population, the people in your poll or in your question is the population. So if you asked all workers that were 30 to 40 in your workspace, or if you asked all 6th graders, or some certain amount of people in a certain situation, and that can be, it ranges from whatever the question is, the total group of people is your population. So one of the things that we need to make sure that we do when we get a population is make it random. So random means every type of person can have a say. If you are pulling a question about if the chicken sandwich is making money at your restaurant, you wouldn't want to just ask people who ordered chicken sandwiches that night. You wouldn't go up to them and say, hey, how is this? We want to make sure that we're doing something good by having it here. You want to go to people of all kinds, people that are eating anything. You want to go up to people that are eating it and aren't eating it, and so it's important to kind of get everyone's opinion on it if you really want a true sense of what's happening in that situation. And so one thing that I really like to do when I'm talking about statistics with my class is to make a dot plot. And when I talk about a dot plot, it's kind of important to understand what a dot plot is. And it's pretty simple. A dot plot is a line graph that has some data points, and you need to come up with what your data points are and find out what the answers to those data points would be. So we're going to be looking here, something that I do with my students is M&Ms. And so I'll say, okay, everyone has a cup or a fourth of a cup of M&Ms. Count how many M&Ms you have and then make a dot plot. So we'll say that this can be red, and 1, 2, I have 2 red M&Ms in my pile. And let's say that this next one is green, and I have 1, 2, 3 green M&Ms in my pile. Okay, we can give the next one yellow, and we can say that I have 1 yellow. Another color is blue, and we can say that we have 1, 2 blues. Brown, so we have 1, 2, 3 browns. And then our last color that is the popular M&M colors is orange, and let's say we have 1 orange. And this is a dot plot, and now you can use stars, you can use X's, you can use dots, and then this can lead to things like bar graphs. So you can make a bar out of these instead of having it the dots and kind of show that this is another way of explaining exactly the same processes and exactly the same situation, just we're using something a little bit different. So from a dot plot and from using the M&Ms, a lot of times what we'll do next is a box plot. And I'll say something like, okay, let's talk about red M&Ms. And I'll say, everyone count up how many red M&Ms you'll have. And so we make our line and we'll say someone could have 0, 1, 2, 3, 4, and maybe 5. And that might change depending on if someone does have 0 or not, if someone has more than 5, if they have 6 or 7, that could change. So let's talk about if we said, let's say one person said 1, another person said 1, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5. So I've worked with this set just to make sure that we come up with some nice and even numbers. But let's say that you went around the class and someone said 1, 2, 4, 3, 1, 5. You want to make sure that these are in order, because what we're doing here is we're going to be looking for a median in several locations. So we're going to have medians, quartile 2s and 3s, and then our minimum and our maximum here. And with M&Ms, it's hard to explain what all of these things mean because there's like ranges that are happening between everything. So when it's a solid number like 0 through 5, it can be a little hard to explain. The next thing that we do is really get into this and talk about like decimal points and things like that. So the first thing that we're going to do is find the minimum of our entire situation, and that minimum is just the lowest number that we have in our set, and that is 1. So our minimum is 1. Now the opposite, we find our maximum, and our maximum is 5. So we have a 5 here. Now our median means middle, so we are going to want to find the middle of our situation, and we want to be precise. So what we do is we cross off the first and then the last, and then the second and the second last, the third and the third last, until we get to a middle number, and there's 3. Now we put that 3 in the middle, and then we like cross it off. We don't need that 3 anymore. If it's 2 numbers, say we find, say we have this set, and I'm just using it for sake, we say cross cross, and there's 2. We take the average, which in this case is 3, and then we cross down the middle. We don't get rid of both of those. We just separate the 2 out. And here's what we're going to do with this information. So quartile 2 is the median of the first half between the minimum and the median of the whole set. This is quartile 2. Quartile 3, mess that one up, is the middle of our last half. So from the median that we found of the whole set to the maximum. Okay, so we're going to go the opposite way so that we don't get confused with our marks. And here's our quartile 2 is a 2, and here is the other side. We just go back and forth until we get 4 is our quartile 3. Okay, now we're looking back up at this plot. Our minimum and our maximum do the same thing. We give it a dot. Minimum, maximum. Our quartile 2, median, and quartile 3, we draw a line. So quartile 2 is 2, median is 3, quartile 3 is 4. And then we connect these so it makes a box. A box plot is a box. And then we draw out our lines to make whisker plots. Okay? And so this is saying that this is quartile 1, quartile 2, quartile 3, quartile 4. And everything that is happening between these two things, quartile 3 is here, I'm sorry, quartile 4. This is the end point. Anything that's happening between these two things is 25% of the data. And same thing here, 25%, 25%, and 25%. So this is where this is hard to explain. Anything between 1 and 2, between 1 and 2 is happening in the first 25%. So these numbers are the first 25%. These numbers are the second 25. These numbers are the third 25, and these numbers are the fourth 25. And it can be a little confusing with just single digit numbers. So a lot of times we'll start going into a little bit deeper with decimals and things like that. So that is box plots. Now, box plots are generally just what they are. It's the dot plots that really help us figure out, like, bell curves are when someone has A, B, C, D, and F, and there's like 2 people that have an A and like 2 people that have an F, and then more people have B's and D's, and then the most people have a C, and then we have this curve that's happening here, and that's a bell curve, and that is where a majority of things like curving grades comes in, is that we don't want a majority of people at F's and D's, we want a majority of people passing, and then the people who are getting better grades are up here in this smaller half as well. So this is where bell curves come from, but it's mostly seen in, like, these are dot plots. And so box plots are kind of their own independent thing, where dot plots can be a little more subjective. So now that we have seen kind of what to do with data, we want to talk about, like, how to get data and what that can look like. So probability is something that we want to talk about. And probability is the event of something happening. Okay, so probability of getting heads or tails if we flip a coin. Now this is something that we start off with all the time. We always start with talking about heads or tails, because a majority of students can understand that this is a 50-50. It's 50% that you're going to get heads, and it's 50% that you're going to get tails. Now, how we figure that out is, if I want heads, there is only one head in the coin, one of them. But there are two options. There's heads or tails. So there's 2 options. So the chances of getting heads out of both of my options are 1/2, which is 50%. Okay? And you can say the same thing about tails. There's only one tails, and there's 2 options. So there's a 50% chance of getting tails as well. So we want to talk about now the difference between something called experimental and theoretical. Okay, so theoretical is this understanding, is that in a perfect world, to get heads is a 50% chance, and it will happen 1 out of 2 times. And to get tails is a 50% chance, and it will happen 1 out of 2 times. This is saying that we live in a perfect world where stats are always going to happen the same way, probability is always going to happen the same way. You're definitely going to get a heads and then a tails, or a tails and then a heads, and it's going to go back and forth, and out of 100 throws, you're going to get heads 50 times and tails 50 times. But that's not how life works. And so how life works is what we call experimental. It is saying, if I threw the coin twice, I might get 2 heads. And that's okay. If I threw the coin 10 times, I might get 7 heads. And that's okay. If I threw the coin 100 times, I might get 40 heads, and that's okay. So we're talking about the more frequently we do something, the more our chances get closer and closer to what the actual thing is. If we threw a coin 10 billion times, we're going to be very, very close to 5 billion heads and 5 billion tails. But if you threw a coin twice, you're likely to get heads twice. I mean, it's just kind of how life happens. So when we talk about experimental versus theoretical, you have to talk about there are so many probabilities that are real in the world that don't really happen the way that they're supposed to, unless there's a lot of experiments happening. A lot of times people will joke about one of your 3 friends is so-and-so, or the loner, and you say, well, it's not me, and it's not me, so it must be them, but that's not necessarily true. There can be a group of 20 people that are all loners that hang out together, and it's not 1 out of 3, then it's all of them, or it's not 1 out of 3 in your group because you're all social, you're all outgoing, that's why you're friends together. So that's a situation that happens a lot. Also, a lot of times, like in a video game, if you play video games where you have to kill a boss to get a reward, a lot of times you won't get that reward because it's a 10% chance of the boss dropping, say, a really great helmet. Because RNG says you're going to get it 10% of the time, it doesn't mean 1 out of 10 times you're going to get it. It means possibly 10 out of 100 times. Or maybe you have to beat the boss 1,000 times before you get the thing once, and then if you did it 100 more times, you'd get it every single time. So statistics, probability, it can be a little confusing, because when we talk about theoretical, we're talking about this is definitely happening. This is real world stuff. This is in our perfect little heads, in our perfect society. But experimental is actuality. Experimental is what's really going to happen. And so the next thing that we want to talk about is, let's say we wanted to find out what it would take to get tails 2 times in a row. And so to find out how something can affect that, how something can happen twice, what we want to do is multiply the chances of it happening once, and then the chances of it happening again. So the chances of getting tails once is 1 tail out of 2 options, and the chances of getting tails another once is 1 time out of 2 options. Now we multiply to find out what our chances of it happening twice are. So we have 1 out of 4, and that is our chances of getting tails twice in a row. And something else that I really like to talk about is something like Powerball. So let's look right here. So the Powerball, select 5 numbers, so 5 numbers from a set of 96 white balls and 1 number from 26 red balls. So let's just say there's 69 numbers, and this is what happens. So basically, when the Powerball gets drawn, someone pulls 1 of the balls out of the 69 balls that are available. They put it back, and then they draw another one, and then they draw another one, and then they draw another one, and then they draw another one. So what we're saying here is that 1 times 1 times 1 times 1 times 1 is simply 1. But 69 times all of those others is actually this ginormous number, $1,564,031,349. So your chances of winning the Powerball are 1 in literally 1.5 billion. And that's something that we talk about a lot, is when you say your chances are 1 in a million, this is the kind of situation that we're talking about, except this is 1 in 1.5 billion. So when we talk about doing something like that, that is exactly like what we're talking about. Something a little more down to earth. If you were talking about drawing a Queen of Diamonds and then drawing a King of Hearts, you would say that there is a 1 in 52 chance, because there's 1 Queen of Diamonds out of 52 cards, times the 1 in 52 chance of getting King of Hearts, and we have 1 times 1 is 1. 52 times 52 is 2704, 2704. So if you were to draw the Queen of Diamonds, put the Queen of Diamonds back into the deck, and then draw the King of Hearts, that is a 1 out of 2,704 chance of that actually being successful. So, today we have talked about statistics, and we have talked about what data means. We have talked about the population. We have talked about random, and it's very important that we remember that being random is a very important thing in finding out data. We've talked about box plots and dot plots, and all of the things that dot plots can really do for us when that comes to making bell curves, when it comes to making number lines and bar graphs. We've also talked about probability. We've talked about how to find it, and we've talked about multiple chances,